We are live. Okay. I believe it's showing up right now.
Yeah, let me check the YouTube to see if we are on that. You have not published yet.
I click go live on YouTube.
Okay.
Yeah. It show up live status right now.
Yeah, that is good. I see that.
Perfect. Let's join the banter. I'm gonna remove. Hey everyone. Let me quickly do system check just to make sure. Leave this one. I think. Yep. Stream is up. All right.
Okay.
Sounds good. Hey everyone. How's your night? How's everything? Let me so give me one moment. Gonna start sharing the stream to like all the channels and everything. Man, gee. We are sharing. Yeah, share. Okay, and one last place, which is Facebook. I think almost 8 so a bit early. Spend this 1 minute to just sharing live stream.
Okay. Be might as well. All right, just share the links on a bunch of groups, etc. So let's get started with quick introductions. So tonight we have Frank from Chainlink. So I will leave it to Frank to introduce himself. Yeah. Hey. Hello, everyone. Good morning. Oh no, good morning. Good evening, everyone. Good evening, every developers. I'm really excited to be here, and thanks for this opportunity that I can share some Chainlink Oracle technologies to all of you. So, actually, just let me briefly introduce myself. My name is Frank, and I am a developer relation engineer from Chainlink Labs. And for the role as a developer relation engineer, so my job is to reach as many developers as possible and to just let every developers know there is something called Oracle in Web3 industry and how you can just make your smart contract, make your decentralized application more powerful And if you need some marketing resources, if you have some technical issues, just reach me and let me know, and I can help you with your program, with your applications. And for the Chainlink Lab, for those who have not heard about the Chainlink is a Oracle. It's an Oracle network, and we are a Web3 company and provide some Web3 services based on our Oracle network to bridge the data and computing resources from Web2 to the Web3 to your smart contract to make your smart contract not only handle the data on the blockchain, but also handle the data from any specific API from any blockchain. Yeah, and that's it. Thank you, Victor.
Hey, so okay, so I really want to do a session on Oracle for the longest time, but haven't done it. So it's great to have Frank from Chainlink coming during like GM Vietnam to get one of these like technical session to be in order. Tonight, I think Frank has like a huge like some practical examples. Well, we're gonna do, I believe, what is that, Frank? What are we doing tonight? Like, tell
Yeah,
everyone.
yeah. Actually, for tonight, we have two sessions. In the first session, I'm going to introduce the theory of Oracle, like what is an Oracle, why we need that, how the Oracle help us in the smart contract building, and how to just power of smart contract with Web2 data. And after that, actually, we have some practice. We have a live coding part. So in the live coding part, I'm going to create an NFT that everybody can just create an NFT tonight if you code along with me. And in this NFT collection, we allow the minters to mint our NFT with a minimum value. See, like if you want to mint an NFT, you need to pay like maybe 0.001 Ethereum for this NFT collection. And also, we want to just create this NFT randomly. Like if anyone of you have experience minting NFT from a very famous collection like a BAYC or some other collections, you will know that every time when you click that mint button, you will get something randomly. And we will know how to do that. We will know how to implement it with a service from Chainlink called BRF to generate a randomness from the Oracle and to just send this randomness to the smart contract. So we can do something like a random NFT, maybe whitelist or raffling. We can do a lot of the different applications with this service. And yeah, I think the last part is to introduce more about the ecosystem of the Chainlink. So if everyone want to start their career, want to just build something, want to just take in participate into some Web3 activities, we also have some resources. I will let everyone know. Yeah.
Oh yeah, like 100% talk. I don't know if you can talk about like maybe talk a little bit about hackathon at the end, toward the end, like finish everything. Talk about hackathon you guys had already. Maybe talk about what's coming up next after coming in the next couple months and so on. Okay, let's get started. You need me to you need my help to like share your screen for anything here. I
Yeah,
believe you can share though. Yeah, I
let
just
me
double check you can share.
share screen
Yeah.
and
I will also switch over to this mode. So like people can see the
yeah,
share screen. Yeah.
I have
Okay.
already.
Yeah, yeah. I see it. Yeah. Add to stage. Oh,
Yeah,
infinite
maybe.
screen. All right. Build hybrid smart contract with Chainlink. All right.
Yeah,
Sounds good. Yeah.
let me just maximize this
Into.
size show.
All right.
Okay, so
I'll just like I really want you to dig deep into the decentralization part of why Oracle is different. Because I'm sure some people are like, why don't we just set up a smart contract, use one of the script in our server to change values, like like price feed and stuff like that. I'm like, why don't we just do that, right? I want you to stress really hard on like why Oracle matters and how like to prevent like bad actors and stuff, right?
okay, yeah, I will cover all the content you want
Yeah.
to learn. And yeah, so can I start?
Yeah, yeah, please. Let's get
Okay,
started.
so
Yeah.
yeah. So for tonight's workshop, actually the title is Build Hybrid Smart Contract with Chainlink. So first, let me just explain what is a hybrid smart contract. For the smart contract, when you build your contracts on the blockchain, that a smart contract only handles the data, can receive and process and send the data on the blockchain, native to the blockchain. But with our ecosystem keep growing in the Web3, we want to build a lot of the different Web3 version of the products, like a Web3 version of the lending and borrowing, Web3 version of the insurance, Web3 version of the gaming. So we need to handle more and more computing result and data from the specific API, from the data exchange, from the cloud providers. We need to handle the data and the traffic from the Web2 world. So if our smart contract can handle both of the blockchain and off-chain data, we call it the hybrid smart contract. It is more powerful than the pure smart contract on the blockchain. And with the hybrid smart contract, we will need an Oracle to help us to bridge the data from the Web2 to the Web3. So tonight, the title is Build a Hybrid Smart Contract with an Oracle called Chainlink. So I think I have already introduced myself. So here is my Twitter and LinkedIn. If you want to reach me, just you can just reach me in this chat in this way. And also you can join the Discord of the Chainlink, and I will help you. Okay, so the content. Just like I mentioned before, we will first introduce why we need Oracle by saying what is the Oracle problem. In a second, we're going to cover the Oracle data service and Oracle computing service. And actually, there are more services from the Chainlink, but because the time is limited, we only cover the data feed and a VRF. And after that, we're going to make use of data feed and a VRF to create an NFT with a feature like a random mint and a minimum value. We need to ask the minters to pay. And I will do that in 20 minutes. So you know how easy to use a Chainlink service. And if you have your laptop with you, I highly recommend you can code along with me. But if you do not have a laptop with you tonight, I will share GitHub repo, and all the codes will be on our official documents. And I also will share a GitHub link to all of you in the comment of this video. Okay, so let's start. So first, the question we need to answer is Oracle problem. What is an Oracle problem? Just like before, I mentioned before. So in the smart contract, we cannot proactively fetch the data from the Web2 world by Chainlink, by blockchain, by smart contract itself. So why is that? Because as we all know, the blockchain is a distributed or decentralized system. So every different node under this network need to have a mechanism to make sure they have the same data in their databases. For example, if I have a blockchain and there is 10 nodes under this blockchain network, and if I post a data or I send a transaction to one of the node under this network, the node will execute my transaction. It will calculate the result of the transaction. And after this node get this result, it will say, hey, everyone, and can you just execute the same transaction? And if you can get the same result, just save this data into your database. So after every node under the network save the same data, actually we call it the data is written into the block, and we call that the data is have already gone through the consensus. So this process is called a consensus, and we have a lot of different algorithm of the consensus. And because we have this consensus, the blockchain, the distributed system, is actually a deterministic system. So what is the meaning of the deterministic system? That means so it can only handle the deterministic transaction. So like 1 + 1. So no matter when, no matter who, to calculate the result of the 1 + 1, the result will always be 2, right? So maybe tonight I calculate 1 + 1, the result is 2. And tomorrow night, someone else calculates the result of the 1 + 1. He will always get the result as 2. But if we want to just handle something called indeterministic transaction, like I want to generate a random number, and I want to get some data from a very specific API. So in this transaction, different node under this network execute the same transaction. It might get different answers. So for example, like I want to know the temperature of the Ho Chi Minh City tonight, and I will check the data from the specific API, and I get the data maybe like 30 or 32 Celsius degree, and another node check the same API. Let's just assume they all have the access to this API, and a different node check the same API. It might get a different answers. Maybe it will get like a 34 or 31 degrees in Celsius from this API. So if the different node get the different answers, well, the consensus cannot be reached. The data cannot be saved into the blockchain. That is why the blockchain, the smart contract itself, cannot get the data, cannot get the computing result from the Web2 API, from the Web2 computing services. And Oracle, by its name, is coming here to just solve this issue. So the architecture of the Oracle is actually pretty straightforward. So we have a centralized node, or we have a centralized server off-chain. We have a server, right? Maybe on the AWS, on the Google Cloud, on the Alibaba, or any cloud provider. And we will run a script in our node. And this script will keep monitoring the status of the smart contract on the decentralized network, maybe on the Ethereum. So if the data is changed, the data is updated, it will be recorded as a request sent from the smart contract. And the script in this off-chain server will check the data from its own data sources and get the data and feed it back to the smart contract deployed on the decentralized network. That is a very, very early stage of the Oracle in this Web3 industry. And we will rely a node off-chain to get the data we want and feed it back to the smart contract on the blockchain. That is Oracle. That is how we can get the data from the outside world. But for this type of the Oracle, this centralized Oracle, there is a problem. It's called a single point of failure. So think about it. The whole reason we want to build the decentralized application, we want to deploy our smart contract on the decentralized network, we can bear with a very high transaction fee, we can bear with the latency. The whole reason is that we want to make our application. It's just transparent, just fair, it's just irreversible in this fair ecosystem, in this blockchain. We will rely on hundreds of or even thousands of nodes to promise our application is decentralized, is safe, is tamper-proof. But if we want to use a centralized node to get the data from the outside world and put it into our smart contract, we actually just makes the whole thing meaningless. So think about it. If this centralized Oracle node is attacked or maybe exploited, then the security of the whole system will be compromised, right? So that is called a single point of failure. Maybe the node is down, so the service will be suspended in maybe a couple of hours, and the user of your decentralized application will lose their access maybe in several hours, or even worse, the centralized node, this Oracle, send the incorrect data to your smart contract, and maybe it will cost a loss from of your users of your protocol. Okay, so the solution or the answer to this single point of failure is called a decentralized Oracle network. So by adding more Oracle node into our network, and we can just allow the different node under this decentralized Oracle network to fetch the data from its own data sources. And after the data is fetched by every different node on this network, the different nodes under the network will talk to each other and aggregate their data together and to generate a final report with their signatures. And the final report will be submitted to the decentralized network like Ethereum. And the smart contract on the blockchain will check the validity of this final report to see if they are from the operators of the Oracle node. So in this architecture, we kind of mimic the trust minimized feature in the decentralized network, in the blockchain. We want to make the process to get the data from the off-chain more safe and more decentralized. So under the architecture, if the some of the node under the decentralized network failed, the whole security will not compromised. The whole security will be promised, and we make this decentralized and safe than the centralized Oracle node. So that is called the decentralized Oracle network, and we also can call it DON, the DON, and Chainlink. So the Chainlink comes to play. The Chainlink is a decentralized Oracle network, and based on this decentralized network, we provide some Web3 services, and the Web3 services have dropped into three types. The first one is a data service. The second one is a computing service, and the third one is a cross-chain service. And the user or the developer of the Web3 can use Chainlink as a developer platform to just get the data from the very specific API or get the price of the very specific asset. Or you can also relay the data from other blockchain to your blockchain. And all these services will be protected by the DON, by the DON, the decentralized Oracle network. So the decentralized Oracle network is actually a bridge, the infrastructure of the bridge. And we have the different services to just make this bridge more useful to the Web3 developers. Okay, cool. So yeah, this slide is just to introduce. We have three type of the service. In the data service, we have 4 services. The data feeds, this is what we are going to use tonight. And the rest of the 3, the data stream, the functions, and the proof of reserve, they all help us to get the data. Maybe some of them are for the low latency data. Some of them are for the unnormalized data, like a customizable data, and some of them are for the financial data in the bank. And the data feed is just for the token price and the price of the commodity and the fiat. We can get the normalized price data through the data feeds. And the second one is a computing service. The first type of a computing service is a VRF. The full name is a verified random function. So it will allow the users to just get a randomness from the off-chain oracle with a proof, and then use the proof to prove this randomness is correct or valid or not. And another one is automation. It is by its name, you know that it is used to automate a function of the smart contract. If you want to have your function in a smart contract to be triggered based on some predefined conditions, or triggered based on some time, maybe every day, every minute, or every week, you can use automation to trigger your functions in your smart contract. And the last one is a cross-chain service. It is called CCIP, the Chainlink cross-chain interoperability protocol. It will help the users to relay the actual data from the source chain, the blockchain A, to the destination blockchain, the blockchain B. And you can use the CCIP to send a cross-chain transaction. For example, you deploy the NFT smart contract on the Polygon. It's a layer 2 of the Ethereum. And some users have their fund in the Avalanche, and they want to mint a NFT from your collection. They can actually use the CCIP to send a transaction from the Avalanche to the Polygon and mint a NFT on the Polygon to their addresses. Actually, you can provide an interface from your application to all the users residing on the different blockchains. So these are all the Chainlink services. And tonight we are going to cover this one, the data feed, and this one, the VRF. And all I'm going to talk tonight can be found on the official documents of the Chainlink. The link is docs.chain.link, and you can find everything there. And tonight we are going to cover the data feed and VRF to build an application with the data feed and VRF. Okay, so let's start. The first one is called data feed. It's actually the service from the Chainlink to just provide the normalized data about the token and the commodity and the fiat from the off-chain to the on-chain smart contract. And the workflow of the Chainlink data feed is like this one. For any services from the Chainlink or any services from the Oracle, we have 2 parts. The first part is off-chain part, and the second part is the on-chain part. So for the off-chain part, we will use the infra we talked about before, called DON, the Decentralized Oracle Network. Remember that? And in the DON, every node will get the data from its own data sources through the data providers. And then after this node gets its result, and this node will get its own result. And after every node gets the result, they will just use a aggregation algorithm to aggregate the data together to generate a final report, like I said before, and submit or transmit this report to a smart contract called a Chainlink data feed. And this smart contract is deployed by the Chainlink. The job of this smart contract is just to verify if the report is valid, if the report has all the signatures from the operators. And if everything is good, the data will be saved in this smart contract, in this data feed smart contract. And it can be consumed by the user smart contract. And also we can call it a consumer smart contract. So as a user, as a developer, if you want to use the Chainlink data feed, you actually don't need to care about all of this part. You only need to know the function name and the smart contract address of this smart contract. And then you call a function within this smart contract, and you just get a price. You just get the data of the price of the asset, and in your smart contract. Okay, so maybe you just want to view what is that, and I can give you this app page. It's data.chain.link, and data feed. Click this one. And actually, you can, let me just zoom in. Actually, you can see this page. This is the data feeds, and we have up to 17 networks, like Arbitrum, Avalanche, Base, BNB Chain, Shadow, Ethereum, and whatever you build your smart contract on the blockchain, and we can provide our service across multiple blockchain, because Chainlink is a service called blockchain agnostic. We don't care about which blockchain is a number one, which one is a number two. And if the blockchain has the developers, if there is someone on this blockchain needs the data of the price of the asset, we will provide our service on this blockchain. So you can develop your application on any blockchain under this list. I think all of these chains are popular in the developer community. And if you have your application on this blockchain, you can use the Chainlink data feed. And for different pair, like 1inch/ETH or some other token/USD, and you just need to get this contract address and use ABI with this contract address. You can just call the functions to get the price of the data to your smart contract. And I will show that in the code along part, and everybody will learn how to do that. And if you want to check the address and check the network, directly go to this page, the data.chain.link/feeds. So, okay. And another thing to mention is actually, there are two trigger parameters for the data feed. The first one is called division threshold. And if the price of this token maybe alternate more than 0.5%, there's going to be a new trigger to update the price data of the asset. Or if the price does not alternate by more than 0.5%, but the time is expired, the 1 hour or half hour expired, there is a new trigger for the update of the price data. And if one of these two trigger parameters is met, the new update will be triggered. So we actually don't just receive a request from the user and just give it a response on this service. But for the other services, you need to send a request. But for the data feed, you don't need to send a request. You just read the data from the data feed smart contract, and the data is always updated based on these two trigger parameters. Okay, cool. So what can we build with data feed? So if you're a builder or a developer want to build something like DeFi, there is a very, very decent chance for you to just to make use of the data feed. For example, like lending and borrowing. If you want to build a protocol like lending and borrowing, you want to allow the users of your protocol to like collateralize your asset on your protocol and get some liquidity back to their wallets. Like I just stake one Bitcoin on the protocol and I want to get some liquidity, like $8,000 to my wallet. That is called lending and borrowing. And in this use case, you need to know the price. You need to know the value of the asset user put on your protocol, right? You need to know what is the price of the Bitcoin, and you can decide how many stable coins and how many liquidity you can just give to the users. And this is use case number one. And if you want to build something like this, you definitely need a data feed to tell you the price of the asset. And the use case number two is a mirror asset. It is also called a synthetic asset. The original idea of the mirror asset is the protocol allows the users not only treat the a blockchain native asset like USD20 tokens or Bitcoin or Ethereum, but it also wants the users to treat the real world asset like a stock market, like a commodity, like a fiat, like any asset in the real world. And in this use case, you can rely the data feed to get the price data of the asset. You allow the user, the trader, to trade in your protocol. The biggest project I think under this type is synthetics. It will allow the users to treat the nearly every stock nearly the blue chip stock in the NYSE and some other big stock exchange. And for the stablecoin, you can use the data feed to decide the value of the collateralization, and you can decide how many stablecoins can be issued by this project. And also for the asset management and options, if you want to just allows the users to know how much value of the asset on chain in their protocol, and you want the users to treat the options and the futures that is super sensitive to the price, you can use the data feed to support your use cases. So if you are building DeFi, the data feed, the Chainlink data feed is something you just cannot skip. Okay, so the next one is Chainlink VRF. So the full name of the VRF is shown here, the verifiable random function. Actually, for the random function, for the randomness generator in the blockchain is quite an issue recently. And the original idea of the RNG is we can just rely on the block hash in the upcoming block, and we can use the block hash on the upcoming block to calculate a number, and we can consider that a random number. But actually, as we all know, in the blockchain, there is something called miners or stakers. It is someone who can just make a settlement, who can just generate a block. And the step to generate a block is that the miner need to collect some transaction in the memory pool, and to use these transactions to create a block and generate a block hash according to the mining rule. And then the block can be written into the blockchain, and it will be the latest block under this blockchain. But if the miner is very, very powerful, if the miner have the more than 50% of the computing resources in the whole network, it can actively choose which transaction can be in the block or which transaction cannot be in the block. So if they can decide the transactions, they can decide the block hash. And if they can decide the block hash, they can decide the random number. So the on-chain random number generator is not that reliable. And the solution is that we can combine the off-chain part with the on-chain part to just use a smart contract, use the block hash and the Oracle node to generate a random number together to not only the random number but also a proof to allow everyone on the blockchain to verify this random number is generated legally. Okay, so the way to use a Chainlink VRF is that we will have a smart contract, And in this smart contract, it is your consumer smart contract. We implement two functions. One function is a request, and the other function is a fulfill. So we use the request function to send a request to the VRF coordinator. The coordinator will use this random number to emit the event to the blockchain. And this event is emitted to be detected by the off-chain Oracle node. The Oracle node will just get the block hash and event log and generate a pre-seed. And use this pre-seed with the block hash, the off-chain Oracle node will generate a seed. And then the VRF, this algorithm, is used to just generate a randomness plus a proof based on the secret key, the private key of the Oracle, and the seed based on the on-chain data to generate these two things, the randomness and a proof. And the randomness and the proof will be sent back to the VRF coordinator, the proxy smart contract of the VRF. The VRF smart contract will just verify if this randomness can be proved by this proof. If everything is good, the random number will be sent back to your smart contract through this function, the fulfill function. So in order to use the VRF, you need to have at least the two functions. The first one is a send a request function. And the second one is a callback function called a fulfillment. And the Oracle node will use the on-chain data and its own private key to just generate a one-to-one randomness based on the data on-chain and off-chain. And everyone else on the blockchain can verify this randomness is generated in this way. Okay, so where we can use the VRF, and I think if you are a Web3 user or if you are a gaming user, you will be aware of that there was a very popular GameFi project in Asia, especially in the Vietnam and the Philippines and even in China. It is called Axie Infinity. And every time if you want to get a new Axie, you need to mint a NFT. And the different Axie have the different rarities. Maybe some Axie, this NFT is the rarest, and few people have these features. But for some Axie, it is not that rare. It is a euro, and maybe it has a low value. So how we can decide if a NFT is rare or not? We can use randomness to see if this Axie is good or not. If what features should be included in this NFT, and by randomly mint, we can implement this feature. And for the Axie Infinity, for the Genesis level of the Axie, they actually use the VRF to produce the randomness to allow the minters to have the different type of the NFT under this collection. And we also can use that to some NFT project like BAYC, and we use that VRF to get different features of the BAYC to just make the NFT minting random. And except for the NFT collection and distribution, we can also make the implement of the raffling and fair selecting. So think about if you have a ideal platform, you have a whitelist, and you want to allocate the opportunities to the different people in a whitelist, how you can pick the users from the whitelist. You can use the randomness to pick the user from the whitelist randomly. And we also have some partners to implement the VRF in their own project to allow the users to have the opportunities to invest into some project that is an ideal platform we know. And we also have a blog article to introduce there are about 35 use cases for the VRF. And if you're interested in that, maybe just check this article. And I will put this link into our stream comment, maybe in the in after this workshop or in the tomorrow. Okay, so all the theoretical part are done, and we are going to code with the data feed and a VRF. maybe in 20 minutes. So if anyone of you bring your laptop with you, if you sit in front of the laptop, you can code with me. And it is very easy. You don't need to create a code from the scratch. We have the samples, we have the framework. We can create this smart contract easily. And before I start, I want to know if there is any questions. If there is any questions, I can just answer the questions and we can continue. Let me check if there is a question.
Yeah, you have to go on to the actual videos, but I haven't seen any question just yet.
Okay, yeah,
Yeah.
let's continue. Yeah.
Let me just drop a note that if you have question, just type it in and we answer maybe the end.
Yeah. So if anyone has any questions about technology, about Oracle, please just drop your question in the chat box. I will answer that. And for now, let's start. So for this workshop code alarm part, we will use a Remix. So everyone knows Remix, right? That is an online IDE to help you to write, compile, and deploy your smart contract on any EVM blockchain. And in our Remix, we're going to create a new workspace. We give it a name. We first select a template. We select blank because we don't want anything in our workspace. And we give it a name like 06 means June, and 06 means the 6th in the June, and GM Vietnam. And we create a new one. And in this workspace, we can create a smart contract called myToken.solidity. It will be our NFT smart contract. And before I coding, I just want to introduce the architecture of the smart contract so you will have a big picture. So the first part of the demo is that we will use a data feed to decide if someone is sending the enough ETH to mint a NFT. So think about this. If you have a NFT collection, you want everyone to come here and mint your NFT, but you don't want people mint freely, right? Because you want to earn some money, because you need to hire the artist to create the metadata, to create image, and that is all the cost. And you want to sell this NFT, so people need to pay for that. But we want to set a minimum value people pay for this NFT. So if they cannot pay the minimum value, the mint function, this process cannot be done, right? Let's see how we can implement this with the Chainlink data feed. Okay, so go back to our Remix console and let me zoom in. And we don't need to actually create our code line by line because we have some tools. One tool I want to introduce to all of you is called OpenZeppelin. The OpenZeppelin is a company providing some standard of the Web3. So for example, if you want to create a ERC20 tokens, you will know what features should be contained in this ERC20 tokens, but you don't need to implement all of these features by yourself because the company like OpenZeppelin, they provide a standard smart contract, and you can make usage of their library to create a ERC20 tokens in like 5 seconds. So let's see how we do that. Go to the openzeppelin.com, and here the contract library. Choose the Solidity contract because we are using the programming language Solidity, and click that one. And scroll down, you can see here is a wizard. And you can use this wizard to create a token smart contract in a very short time. So here you can see we have the different token standard, the ERC20, the ERC 721 and the ERC 1155. So for now, we are going to use this one. This is the token standard for the NFT. The NFT, which is called a non-fungible token, and the technically speaking, it is following the token standard called ERC 721. And here we can give it a name called myToken and a symbol called MTK. You can name it whatever you want. And here you can see the features. And in our NFT smart contract, we want it to be mintable, right? We want somebody to mint our NFT. So we click this we check this feature, the mintable, and also check this one. it is to make the token ID increment after every mint transaction happens. So first person mint NFT with a token ID 1, and the second person mint NFT with a token ID 2. That is called auto increment IDs. And we also want the URI storage. This is for the metadata, because in our smart contract, in our NFT, we want someone to see the image, to see the metadata. So when you check an NFT collection, you will see the different images, the different features, the different descriptions for each different NFT under the collection. So actually, all this data is called metadata of this NFT. So the URI storage is a feature we need to implement in order to allow our NFT to have a metadata. And this metadata can be rendered by the front end, like OpenSea, to just show everyone that there is something in this NFT. You can see an image, you can see the description, and you can find the feature of this NFT. And up to now, we have already complete our NFT smart contract. So copy everything in this console and go back to our remix and paste everything here. And we have the alert, pasted code alert, because the remix just found us copy everything from somewhere it does not know. So we just tell him that we are good, we know what we are doing. And so for now, we have our NFT smart contract. So this is my token. It inherits the three interface, not interface, the smart contract, the URC701, the URI storage, and Ownable. And we can see here the safe mint. This function is actually the function we care about. So it takes the two parameters. The first one is the to, it is the address tab. And the second one is the URI, it is the metadata. It is URI to the metadata. And in our smart contract, we actually don't need to for simplicity. We just want to just tell the smart contract and the people who send this transaction, the people who call this main function will be the owner of this token. So we can use message.sender, and or you can keep that. It does not matter. I just want to make it simple. And the second parameter URI, and we actually don't need to input that manually, because I have already created three URI for this NFT. Let me just copy that. I copy that into the remix. I will create some attributes, the metadata for NFT, and paste that here. So we have the three metadata: the metadata Shiba Inu, the metadata Husky, and the metadata Bulldog. Actually, there are three very cute dog image I created with AI, and I saved that on the decentralized storage called IPFS. And if you go to this link, you will see that there is a JSON file to just tell the OpenSea or tell any rendering platform that we have this description, we have the image, we have something else. So the OpenSea will know that the image and the description of this NFT. So because we have this metadata, and I can just use maybe this one in our safe mint function to replace this one. So for now, if I compile that, use the Ctrl+S to compile that, or if you are using Mac, use the Command+S to compile your smart contract. And then we actually finalized, or we actually complete the simplest NFT smart contract. But there is one thing we want to do. We want to make sure the minter pay enough, or maybe not enough, minimum ETH to mint a NFT, right? We want to just implement this feature. Maybe we want to charge like $1 before people mint a NFT from our collection. And how we can do that? Maybe we want to write a require and require, and use a message.value. Message is actually an environment variable, and it is a built-in
typo, sir. So you got a typo. Require.
Oh, okay. Sorry.
Yeah.
Require. Yeah. Thank you, Victor. And the message is a built-in environment variable in the Solidity, and we can use the .sender to know the address who sent this transaction. .value to know how many is amount in this transaction. and we want to make sure it is greater than the minimum value, right? We want to have the variable to just define what is the minimum value we want. We require the minter to pay, and we want to create a new attribute here, the minimum payment, and we can use a u into 56, and we give it a name called minimum payment. And I don't know if everyone know about that in the Solidity, in this programming language, we do not have the floating data type. So you cannot use the 0.01 ETH. You cannot see that. You cannot write this. If you want to use a floating data type, you need to use V. That is another unit in the Ethereum. So 1 ETH is equal to 10 power to 18 way. So if I want to make it a very small number, like $1 USD, actually it is very big in the Solidity. So if I want to define 1, it is actually the 1 multiply 10 power to 18, and the unit of this one is actually weight, and this is actually the $1 US. And we need to use this attribute, and maybe let me make it a constant, and use this minimum payment in our mint function here, and make the message value greater than the minimum payment. And if it is not, give it a reminder or give it a notification. Please send more ETH, right? And a semicolon to create this one. But here is what is wrong with that? Oh, because we ask people to pay the ETH, so we need to make it a payable. Yeah. And if we have this keyword, the function is a payable function, and people can just pay with some amount of the if to when they call these functions. And we don't want the only owner, because we want everybody is able to call this function. And but actually there is a problem. So for the message.value, it's actually the message.value is actually the amount of if, right? The amount of if. But for the minimum payment for this variable, it is actually the value of US dollars. These two are different, right? We need to just convert the amount of the if to the US dollars. So how we can do that? Remember that we have the Chainlink data feed, and we can just convert the ETH amount to a USD dollar by multiplying the amount of the Ethereum and the price of the Ethereum, so we can get the value of this amount of the ETH, right? So we can create a function called convert ETH amount, not amount, maybe make it simple, ETH to USD. And we give it a one parameter, u into 56. It is ETH amount. It is also the messenger.value. And we need to return a u into 56. This is gonna be the value of this ETH amount. And we'll make this function, and maybe we'll make it a public. Okay, cool. So for now, we will see how we can implement these functions. And as before, we don't need to write it line by line. We have the helper we have the Chainlink official document as a helper. Go to this website, docs.chain.link, and you can find 6 services provided by Chainlink. So go to the data feed, this one. And this is documents to introduce what is the data feed, how we can use that, and the data feed addresses we provided across the different blockchains. And we can go to the getting started here. Maybe I make it bigger. In the left panel, in this content, go to this getting started, and we can find a sample code here. And let's see how we can just implement the data feed. The first one, we need to import the interface of the data feed. It is called an aggregator v3 interface. remember that we mentioned that the DON will aggregate the data price together, and the aggregator v3 interface is actually the smart contract to receive the result sent from the Chainlink DON. And I'll copy that back to the remix and add it here. This one, import the aggregator. And after the importing, we will need to create a variable based on our interface. The data feed attribute. The data feed, yeah, and it's gonna be aggregator v3 and data feed. We give it a name. And if we have this data feed, we need to instantiate before we use it as a handle to get the data from the Chainlink. So I'll give it a data feed equals aggregator interface. And there is one parameter we need to input here is the data feed smart contract address. And where we can find it, go back to the documents, and here the data address, the feed addresses. And we can go to this page. In this page, we have a different network. You can see here the Ethereum, BNB chain, Polygon, Gnosis chain, Avalanche, Phantom. Because we are using the Sepolia, we're going to use the Sepolia testnet. So we click this button, this Ethereum, and scroll down. This is for the mainnet, right? This is for the mainnet, and this is for the testnet, the Sepolia testnet. And we will find the ETH to USD dollar to this pair. So we copy this address. This is the address we're going to use in our aggregator, and paste this address to in the constructor. Just paste it here, because we are going to use Sepolia. If you are using a different testnet or different mainnet, the address will be different. So we add a comment here, like this is hard coded for Sepolia. Okay. So after this line, the data feed is instantiated, and we can use the data feed as a handle to call the function in this smart contract with the address here. And how we can call that, go back to our sample code. You can see here in the sample code, a new variable is declared, and the variable is instantiated with the address, but we use a different address. This address is for the BTC/USD. That is the price of the BTC. We don't need that. We need the price of the ETH. And the third function is a get Chainlink data feed latest answer. And we copy that one, copy this one, and paste it into our remix, and paste it here. Make it a format prettier. And we have this function. And if you check this function, you will see that data feed dot latest round data. And if you call this function, you will get a list of the variables, the round ID, answer started at, timestamp, and answer in rounds. And we don't care about the rest of the answers. We only know the price data of the ETH. So we get this answer and it returns answer. And if we have this price of the ETH, and we can directly go get Chainlink data feed latest answer, and we will get the price of the ETH. And because you can see here, the return data type is int, and we're going to use u into 56. So we do a type conversion, use u into 256, and add a parenthesis here. And we already get a price of ETH, and we also need amount of the ETH that is in our input, the ETH amount, multiply this one, and we can return this result. And actually, by doing this, we convert this ETH amount to the ETH value by multiply this one and this one. But there is one thing we need to care about is that remember that for this one, we have a 10 power 18, and for this one, we have a 10 power 8. The reason this one is 8 is because any token to the USD have the precision as 8, has 8 as a precision. It is not 18, it is 8. So what we need to do is just slash this one and remove that. So the amount multiplies the price and slash the unit numbers, and we can get actually the price of the ETH, not price of the ETH, the value of the ETH amount, right? We can get the value, and let's see what is running here. Yeah, we can make it a view. That means this function only check the data, but not to change any status on the blockchain. Okay, so we have that convert ETH to USD, and we can use this function in our mint function. Just write it here. And by doing this, we actually compare the USD value of the asset sent by the minter and the minimum payment in the USD. So they are in the same unit, and we can do that. We can just set a requirement for the minters to just to say that please send more ETH if they do not pay enough ETH. Okay, let's just deploy this smart contract to the blockchain. And if we want to use the Chainlink services, we need to deploy it on the testnet. And we need to use the injected provider, which means that the remix will use the network you set in your MetaMask. And for now, I set the Sepolia in my MetaMask. So I'm going to use the Sepolia testnet. So in the injected provider, we have this smart contract compiled, and I can click this button, the deploy, to deploy my smart contract. And I'm going to copy my wallet address here and paste it here, and click deploy button. So MetaMask pops up, and click confirm to deploy the smart contract. And we can check the status of our transaction here, the contract interaction. This transaction is pending, and we maybe wait for like 5 to 6 seconds to so that the transaction can be confirmed. So if the transaction is confirmed, we will have our smart contract here. And you can see we have the function as a save mint. We have a save mint function here. And for now, if I click this function, there is something wrong. The gas estimation failed, and we have a error information. Please send more ETH. That is the same thing we set here. Please send more ETH. That means here, this one. Please send more ETH. That means the requirement we set here actually take place, and the data feed actually check the amount paid by the sender to see if the sender pays enough value. And if we want to pay enough to call this safe mint successfully, we need to know how many ETH is greater than $1. And if you don't know how much about that, I recommend that there is a calculator, the way to ETH. If you Google this thing, there is a unit converter. And if I click that one, this is just a UI created by someone else. I usually use this UI to convert the units between the GUI, and the Ether. So for now, the price of Ether is like $3,000. So I going to 0.001. So that's going to be the $3.84. So if I put the value calculated from here into the remix in this one, the value, and use the unit as weight, actually I pay the $3.84 to call this function, and it is greater than the $1. It should be triggered successfully. Let's try save mint. Oh, and this time our MetaMask pops up. That means we just pay enough ETH to call these functions, and I click confirm. I successfully call the save mint function within these transactions. Let's see, this transaction is done. Oh, it's confirmed already. And to check it is successful or not, we have two ways. The first way, we can go to the balance of. We can check the balance of this address to see if there is one NFT under the address. Check this one. You can see the result is 1 here. Maybe it's too small. This one is 1. And if we check the token URI of the first NFT, we check that, we have the IPFS link. And if you want to see that more visually, you can go to the testnet OpenSea, And this is the OpenSea exchange. The OpenSea, by the way, is the biggest NFT marketplace in the world, and it also provides a testnet environment for you to test your NFT and build your applications. And if you're if this is the first time for you to log in with OpenSea, you will just connect your wallet. And if you have already connected, go this one, the profile, and go to the profile. We can see here. This is an NFT we just minted from our testnet smart contract. If you click this one, go to this NFT, and you will see the NFT is minted 1 minute ago, and there is a value we need to pay to mint this NFT. So for now, we have already complete our demo part 1. We set a minimum value to the for the senders to mint this NFT. And now we are going to the part 2, the NFT random mint. In the part 2, what I'm going to do is that I want to make this mint process random. And if you click the mint function, you will get there are 3 possibilities. You will get a Shiba Inu, you will get a Husky, or you will get a Bulldog. It really depends on the randomness returned by the Chainlink VRF. If the random number is the 1, if that is 2, and if that is 3, we will have the different NFT minted. We call it a randomly mint NFT. So how we can do that? So go back to the remix, and we're going to add the Chainlink VRF into our NFT smart contract. Let's start. As before, we need to go to the documentation of the Chainlink and go to here, the Chainlink VRF. Go to the VRF documentation. For this one, the similar architecture, you will see all the content on the left side panel, and in the Chainlink VRF v2.5, you can go to the build with VRF 2.5 and click this one. Get a random number with subscription. Go to this one, and you will see, like before, here is a sample code for you to, let me just zoom out. Here is a sample code you can use to add the VRF service into your smart contract. So for this one, the first thing you need to do is import to smart contract created by Chainlink. Copy these 2 lines, go to your remix like before, we go to this one and paste it here. We import the VRF consumer base. It contains some necessary functions you need to use to send a request to the Chainlink VRF. And the second one is a VRF v2 plus client that contains necessary data type, the struct you need to use to create or wrap your request into a data struct. And after you just import these 2, and you need to also make your smart contract inherited from this one, the VRF consumer base v2 plus, and add a comma here, and add that one. That's compiled again. And now we have the 7 errors. So for some errors in this example, it is because the on-ball smart contract and the VRF consumer base v2 plus share some functions with the same name. So for simplicity, I just remove this one because we don't use the only owner access controller in our smart contract. So I remove that one. So if you want to use that one, we have some way. We have some solutions, but that is not a focus of this workshop. So I just remove that one. And I need to remove this one. And in order to use that VRF consumer base v2, we need to also add constructor here because we inherit the VRF v2 base v2 plus. We need to call the constructor of this VRF, and we need to add a parameter here. The parameter is a coordinator address, and I can see here. Because this is hard-coded for the Sapolia, so we will use the same coordinator address and copy that, go to the remix and paste it here. And if you want to find this address for the different blockchain, as like before, you can go to the method and not this one, Chainlink VRF, and we have a supported network. And go to this configuration page in this one. You will see we have already supported a lot of the blockchains like Ethereum and BNB chain and Polygon, and you can check the list in this page to see all the supported blockchains of the Chainlink VRF. And copy that and paste it here, and let me just compile it again. And we only have one issue. Let's see what is that. That is should be marked as trap. Okay, so that one means that we need to implement a function called fulfill random words. So like before, I introduced about a Chainlink VRF or any other services provided by Chainlink. Usually, if you want to send a request, you need to have a function called fulfill. You need to allow the Chainlink service to just make a callback to your smart contract. So you need to contain this function in your smart contract. So let's see how to write that. Go back to the sample code. And here is a fulfill random words. But before we're doing that, there is one thing we need to do is we need to add some configurations like this one into our smart contract. And I will explain them a little bit after I paste it here. And in the attributes declaration, we will see these are the VRF config. And I paste everything here. Let me remove the comment and make it more beautiful. Remove that. And remove that. We don't need this too. And yeah, these are the VRF configurations. We will have a subscription ID. I will explain it more later. And we will have a key hash. This is a mark to allow the VRF to know what is the gas price you allow the VRF to use to send the response back to your smart contract. And this is a callback gas limit. That means how many gas limits you allow the VRF to use when they want to send to just call the callback function in your smart contract. Maybe we want to make it a 5, maybe make it more bigger. And this one is the confirmations, like how many blocks we need to wait before this transaction is done. And this is a number of the random words you request. You can request up to 500 random numbers per time, but we just need to one this time. We only want one random number and use this random number in our smart contract. So these are for the VRF config. And this one, the sub ID, I will explain it later, but for now, we need to just input from the constructor. We remove that, use the uint256 called sub ID, and assign the S subscription ID equal sub ID. Okay, so we assign this sub ID to the S subscription ID here. And after that, we can just continue. So in the safe mint, before we just mint the NFT and we set NFT with a URI. This is hard-coded, and there is only one possibility, like Shiba Inu. No matter who, no matter when people mint this NFT, he will get a Shiba Inu. But for now, we want to make it different. We want to make the metadata different based on the random number returned by the Chainlink VRF. So we create a new function. Actually, we don't need to create it by ourselves. We go to this one. We create a random function. We copy this fulfill random words function and paste it in our remix. And we have this one, the fulfill random words. This function will be called by the Chainlink VRF. And actually, we don't need this one. What we want to do is that we will have our random words, right? And this is an array because we only require one. So we need to use random number words with the first index. That is our random number. We make the uint256 random number equals to that. And actually, because we only have the 3 images, we only want 3 possibilities, and we can use this number mode 3. And there are going to be 3 use cases for if the random number equals 0. That is use case 1. and else if random number equals 1, that is use case 2, and else that will be the use case 3. So based on this result, based on this random number as a result of the random number mode 3, we have the 3 different possibilities, case 1, case 2, and case 3. In these different cases, actually we comment it here, we want to call this function, the set token URI. We want to set a different metadata to our token ID with well, based on the random number returned by the VRF. So maybe first one is a Shiba Inu, and the second one we want to make it a Husky, and the third one is like a Bulldog, B-U-L-L. Okay, so cool. So for now, we have already completed our fulfill random words, and we comment this transaction in the safe mint because we only want to mint our NFT in the safe mint and set the metadata of the NFT in the callback function. So this function will be called by the VRF. So there is another problem. So for the token ID here, how we can know that? Because we have the token ID here in the safe mint function, and we also want to use the token ID here in the fulfill random words function, but they are in the different scopes. And we need to create a new mapping to connect them together. Like here, we want to create a mapping for token ID and request ID. And it's going to be a mapping, and its key value is U into 56, and value is U into 56. We call it, maybe make it public, and we call it request ID to token ID. So we can just bind the request ID with a token ID together. And in the mint function, after that, we don't need this line. After that, we want to send a VRF request, right? So how we can send that? Go back to the sample code, and here we have a send function, and copy that, go back to the remix, paste it here. And for now, we have a request ID because every time when you send a request to the VRF, it will return a request ID to your smart contract. And we are going to create a U into 56. It is called request ID here. And after we get this variable assigned, we can add that to the mapping. The request ID to the token ID with the request ID is equal to the token ID. So we have already created the connections between the request ID and the token ID. And in our callback function, we can use the same thing, request ID to the token ID, get this one, right? In this parameter, the request ID, and assign it to a U into 56 token ID. Okay, cool. So for now, we have already get our token ID, get a random number, and based on the random number, we set a different metadata to the token ID. And let's see what is wrong. Oh, for here, it's set false. Okay, so I think for now, we are almost done. Let me just recap what I did just now. I imported 2 contracts. One is a consumer-based contract, one is a client contract, and we need to use some attributes and functions within this 2 smart contract to send and receive the VRF request and response. And in our mint function, we mint this token and save this token ID in the mapping and send a VRF request. And then we create another function called a fulfill function. It will receive a request ID and a random word sent back by the Chainlink VRF. And we are going to use the random words to mode 3 to create 3 possibilities. And in the different possibilities, we set a different metadata to the same token ID. So when the user sees this token ID, see his own NFT, he will see that there are 3 different possibilities, 3 different images in their NFT. Okay, so next, let me just go to deploy our smart contract. Let me just remove the older one and create a new one. And before we deploy the new one, we have this one parameter, the sub ID. So what did that? So before every time you want to send a request to the VRF or send a request to any Chainlink service, you need to have a subscription and add some token into the balance of this subscription. And let me create that one. Go to the vrf.chain.link, and here is the front end of the Chainlink VRF. And here is a button called Create a Subscription. And in this one, your email address and project name, you can skip that and click this button, Create a Subscription. And your MetaMask pops up and confirm this transaction. Then for now, you are just creating a VRF subscription to receive any request from the registered smart contracts. And let me just wait several seconds for this block to be done. And yeah, let me just wait several seconds. Actually, this transaction is done, and the UI need to show that. And for now, the subscription created successfully. And the second step is to add funds. Let me maybe add 30 links into my sub and fund subscription. By doing this, I actually transfer 30 link tokens from my wallet to the VRF subscription. So for now, our subscription will have a balance. And every time when the consumer smart contract sends a request to this subscription, we know where we can just charge the fees because you have already deposited some link tokens into your subscription. And by doing
for testing, I think you guys have a faucet, right? To drop some link for testing when you're practicing.
Yeah, if you want to get some link, go to this faucets.chain.link, this website. And here you can just check the mark here and log in by your GitHub to verify you are not a machine, you are not a bot. And just click this send request, you can get some test tokens, the 25 test link and 0.25 test Ethereum. And here you can see we provide the test tokens in a lot of the different blockchains in the testnet. The Arbitrum, Avalanche, and Base. Actually, the Avalanche and Polygon are my favorite ones because they are so fast. And the Sepolia is a little bit too slow, and it is sometimes very hard for you to get the test ETH. Usually, this faucet is easier to be used up, and you need to find some other faucets to get the test Sepolia Ethereum. Yeah. But for now, it works for now, and you can feel free to get some test tokens from this website. Okay, so for now, this subscription is created, and next step is to add consumers. But we have not deployed our smart contract yet, so I will do it later. And click that button, it will redirect you to the subscription page. In this page, you will see that this is a network your VRF sub are based on, and this is a sub ID. That is what we need for our constructor. And this is the admin UA address, and this is the balance. And in the VRF, you can either pay link or if, and we have two options. And this is the version of the VRF. So for now, we have already created a subscription with some funds. And I click this icon, this one, copy the ID and back to the remix and paste the sub ID here. Then I can deploy my NFT again. And with the MetaMask, we can confirm the transaction. So the smart contract can be deployed. Let's see, my transaction is pending. If you are using some layer 2 testnet, it will be very fast. But actually, for some layer 2 testnet, the problem is that usually it is not that latest to the EVM versions. For example, for the Sepolia, the EVM versions is a Cancun. But for some other testnet, it is still using Shanghai, the last EVM. So if you are using the high version of the Solidity, sometimes you cannot create a transaction and send to this testnet successfully because it is use the older EVM version, and you need to downgrade your OpenZapDing smart contract. It will create more complexity. So it is very safe to use Sepolia. But for other layer 2 testnet, you need to care about that if they are implementing the latest EVM version. And for now, our NFT has already deployed successfully. And let me just add this smart contract into our sub. Not this one, this tab. Add consumer. Just add your smart contract as a consumer under this subscription, because the subscription needs to know who can use the font in here, who has the permission to use this font. So you need to add a smart contract here. Add a consumer and sign with MetaMask. Okay. So for now, you're adding the NFT smart contract into this subscription. And don't okay, so for now, we need to wait this confirmation. We need to wait for the confirmations. And actually, this one is still pending. Oh, it's confirmed. Maybe after several seconds. Okay, the consumer added and close. You will see under the consumers, this address is added. That means the request from this address will be processed by the VRF. And the request from other addresses will not be processed by the VRF because they are not allowed to use a balance here. And for now, let me just send my Mint transaction using this button. And let me go to the converter to copy this this value, and go back to remix and paste the value here. We can just pass the data feed requirement and click Save Mint and confirm. So by clicking this button, we will just random mint a NFT, and also we will send the request to the VRF. So when this transaction is confirmed here, let me just wait like yeah, it is confirmed. And if this transaction is confirmed on the blockchain, it will be detected by the Chainlink VRF. So if we go to the VRF front page and refresh the page, we will see here, there is a pending request. That means the VRF has already detected there is a request from the consumer smart contract. This is a consumer, the same address here. And this is a transaction hash. That is the status of this request. And that is a max cost, but actually it will not cost this much link. It is a theoretically maxed cost. So we need to wait several seconds, and the VRF will calculate a randomness and send this randomness back to the smart contract in this function, the fulfill random words. It will receive a random words and use this random words to mod 3 and execute the following logic. Let me refresh that again.
Yeah, once it's done, can you show the transaction on Etherscan? Like the transaction.
Okay.
Yeah.
Sure.
After it's done. Yeah.
Yeah, actually it is done already. And this is the transaction hash. And in the history, we have 2 tabs, the recent fulfillments and the events. Under the recent fulfillments, that is all the fulfillments the VRF has completed before. And if you click this one, it will direct you to the Sepolia Etherscan. And this is the function to call the fulfill random words function by the VRF on your smart contract. This is your smart contract. And if we go back to the OpenSea and go to your profile, and we will see there are going to be 2 NFT, I think. Yeah, 2 NFT. And yeah, unfortunately, we have the same one. That means the random words mode with 3, it use the case 1. it's the random number is a 0, so we still mint a NFT with the metadata of the Shiba Inu. But actually, it is possible for any minter to have these two different metadata on its NFT. So that is the usage of the VRF. And this is the front end of the VRF. This is our use case. We use a NFT smart contract to just send a request to the VRF here and get a request ID, and use the request ID here to get a token ID and to just have a possibility and create a metadata for this token ID. That is called NFT randomly mint. And yeah, I think that is pretty much I want to share about live coding here. And I will just upload this code into my GitHub, and I will share that link in the comment of this live stream. And yeah, for the last part, and there's one thing I want to cover. It's a hackathon provided by Chainlink. So we actually in every year have the two hackathons, the spring hackathon and the fall hackathon. And if you go to the page hackathon.chain.link/hackathon, you will see that we have a hackathon from the April 29th to the June 2nd. It is just ended. This is a spring hackathon of the 2024. And there is $500,000 US in the pool. And we will allocate this dollars here into the different prices. You can just create a finance services, cross-chain solutions, and AI, and gaming, and consumer apps, or you can run for the Chainlink grand prize. So the larger the prize is $50,000. And if you are the winner of this hackathon, the $50,000 USDC will be sent to your wallet address, and you will be the winner. So if everyone you want to build a application, you want to start a career, you want to just make a startup, it always a good way for you to start your project, start your career through a hackathon. Because in the hackathon, you can find some friends, you can form a team, you can just get some ideas of what to do. And if you don't know what to do with Chainlink, actually, we have another website called DevPost. This is actually a hackathon website. In the DevPost, this one, click this search button. If you search Chainlink, you will see the Chainlink hackathons in this year, last year, and the year before last year. And if you click anyone, like this one, it is a Constellation hackathon happened in the last November to December. And you will see all the all the submissions, the project gallery. And if you don't know what to do, maybe just check what others did in the last hackathon and in the history. Maybe you will get some ideas. And we will list all the winners, winner project and non-winner project. There are going to be like 300 to 400 projects submitted for every hackathon. And for the winners, we will have maybe 50 to 60 winners per hackathon. So in total, 400, but for prizes like 50. So it is not very hard to get a prize. And I encourage every developers, every builders to come to this hackathon and just train your skill, know the friends, and win the money, and also make your project to be seen by the other builders or the VCs or anyone you want to show. And it is a very good opportunity for you to do that. And for the Chainlink hackathon, it is totally online, and you don't need to pay a single penny for the hackathon. You just create your project in the GitHub, and then record a 5-minute video to just introduce what you did in your project, and that's it. You just submit this repo link and video link, maybe on the YouTube, to the dev post, and we will review your project. And if you are good enough, we are very glad to grant the prize to you. And yeah, and that is for the Chainlink hackathon. And one more thing, the Chainlink conference. We have one conference per year to just introduce our product and invite some like famous people in the Web3 industry to come to the conference to introduce and social networking. And for this year in the 2024, and we will have our conference hosted in Hong Kong. So if you are interested in that, maybe just come to our SmartCon, and we will have the 2 or 3 days hacker house prior to our SmartCon. And if you are a builder, welcome to our hacker house prior to the SmartCon. And yeah, it's a pretty long time. So the time was set for 1 hour. I think I spent 1.5 hours. And thank you, Victor. Thank you for that. Yeah. And yeah, that is pretty much I want to share tonight. And thanks everyone. Thanks for your coming here, and thanks for your time. And also big thank to Victor. Thanks for the buildstation for this opportunity for me, and I'm really appreciate.
Yeah. This so I drop a bunch of links inside the chat already. So the faucet links, data, VRF, docs, everything. So thank you so much, Frank, for showing this. Once you have the GitHub ready to pass on to me, I'll just go directly to the video, just comment it in so people know. I will also add that into the descriptions and so on. So just a quick reminder, if you are in Vietnam this week for GM Vietnam, we also will be hosting a meetup on Sunday, June 9th, in Ho Chi Minh. You can check the site event list, buildstation. During that session, I will also show anyone who comes. So okay, Frank show everything on a testnet, but lately it's really hard to get Sepolia ETH. So I will show you a trick to do local mockup using mock contract provided by Chainlink to do local mockup, test on Anvil, and using just a local node. So then that will save you the effort. I've been accumulating Sepolia ETH. But if you're rich, you can also just go on layer 0, just buy some. But I don't think you should. I don't want people to do that. So yeah, I will show you guys some trick to do some local mockup, and there will be some small prizes for you to start implementing a couple stuff. Hopefully, and we have the GitHub by then, so you can retry the whole flow, try yourself to actually mint out some NFT. There you go.
Okay, thank you, Victor. Thank you.
Cool, man. All right. I think that's it for today's live stream. All right. Thank you so much, guys, for joining. Thank you, Frank, for joining this session. We're going to end right now. Thank you so much. Bye-bye. Bye-bye, everyone.
Thank you. Bye.
Yeah.
Bye.
Guys, have a good night. Bye-bye.